Alright, here is our lecture video for section 6.7, Solving Radical Equations and Inequalities. This is our last section of chapter 6, and we're not actually going to focus on inequalities, we're really just going to focus on equations, so we don't have to worry about that. Just to start us off with some notes here, what is a radical equation? Well, radical equation includes a radical expression. How do we solve it? I want to make sure you guys write down that bullet point right there. You can solve radical equations by raising each side of the equation to a power. So we're going to be raising things to exponents to get to other stuff to cancel out. And here's our steps how we're going to do that. First thing we want to do is isolate the radical on one side of the equation. Just like we would isolate an x when solving for x, you want to isolate the radical to one side of the equation. Step 2. Raise each side of the equation to a power equal to the index of the radical to eliminate the radical. Again, our goal is to get rid of the radical. So just like when we're solving the problem, x squared equals 3. Say we have x squared equals 9. Sorry, I don't know why I picked 3. Equals 9. To solve this, we all know, oh, you just have to take the square root of both sides to get x equals plus or minus 3. Well, basically, we're just going backwards. So if this was x to the 1/2 equals 3, well, to solve this, we want that 1/2 to become 1. So we would square both sides to get that x equals 9. And it's just kind of going back and forth like that. And then for these equations, our final step is just going to be finish solving the equation for x. Something that I do want to point out that's going to happen in these examples is sometimes we're going to have an extraneous solution, which just means it's a solution we get, but it doesn't actually work. It doesn't actually work for our problem here, which means sometimes we're going to have a problem that has no real solutions, and all this means is you have to check your answers. You have to plug what you get for x back in to make sure it actually works. So let's try an example. Example 1, solve each equation. So our first step is to isolate the radical. So we want to isolate this expression right here. So we need to get rid of this plus 4. Well, just like when we're solving equations, we could subtract it to the other side. To get that the square root of x plus 2 equals 7 minus 4 is 3. From here, to get rid of this square root, well, I'm going to square it. They're opposites of each other. We can think of this as x plus 2 to the 1/2 power. I'm going to square it, and if I square that side, I also need to square this side. Those cancel out, so I'm just left with x plus 2 equals 3 squared is 9. And then to finish up, I'll subtract the 2 to get that x equals 7. And hopefully you guys remember, oh, I have to check my solution, make sure it actually works. So to check this, I'm literally just going to plug 7 in for x and see if it comes out to be true. So I have the square root of 7 plus 2 plus 4 equals 7. 7 plus 2 is 9. Square root of 9 is 3. 7 equals 7, so we're good to go. That's our solution. So whenever we have a problem that looks like part B over here, it's a little bit different. Us isolating these radicals right here isn't going to really do much. Again, your goal is to isolate the radical expression. So since this is just the square root of x, it's okay to be on this side, but we want whatever has the plus or minus on the inside to be by itself. So just like we did in the last example, this is like x minus 12 to the 1/2 power. The opposite of taking the square root is squaring something. So what I do to one side, I want to do the other. Well, that ends up canceling, so we're just left with x minus 12. I hope you guys are guessing, yes, we are going to have to FOIL this. That's why I put the parentheses there, so you guys would know how to FOIL. So I'm going to rewrite my expression like so. And I'm going to FOIL.
Canola, olive oil, palm oil, argan oil,
Alexa, quit listening. Sorry about that. So now I'm going to FOIL. So I just have x minus 12 on this side. 2 times 2 is 4. Minus 2 square root x minus 2 square root x plus the square root of x squared. Can't really see my plus sign right there. Plus the square root of x squared. So if I go to clean this up a little bit, still just have x minus 12 on this side. 4, combine like terms right here to get minus 4 square root x. Square root of x squared, those just cancel and this just becomes x. So now let's move some stuff around and see what happens. Well, I can combine these two right here. So I'm going to subtract this 4 to get that x minus 16 equals negative 4 square root x plus x. Well, I see that I have these two x's over here too, so why don't I go ahead and subtract my x's? Well, that's just 0, so I'm left with negative 16 on this side. Well, this is also 0, so those x's just canceled each other out, so you're just left with negative 16 equals negative 4 square root x. I can divide by negative 4 to get that 4 equals the square root of x. And now, to get rid of this square root, I know the opposite's going to be squaring it, so I can square both sides to get that x is 16. So I'm not done yet though, because I still need to check my answer. So I'm going to come over here and I'm going to check my answer. I'm just going to plug 16 in for everywhere I see an x. There's 2 this time, so you got to be careful with that. So we have 16 minus 12 equals 2 minus the square root of 16. 16 minus 12, that gives me 4. Square root of 4, 2 minus square root of 16 is still just 4. So then looking at this over here, square root of 4 is 2, 2 minus 4 is negative 2. That is not true. So that is not a solution. So this problem actually has no real solutions. No real solutions for that one because 16 didn't work out when we checked it. It's an extraneous solution. That's why we always have to check it. So why don't you guys go ahead and try these guided practice ones on your own. Pause the video and try these on your own. Come back when you're ready to check your answer. All right, so the first thing I want to do is I want to get this radical part isolated. So I'm going to add the 1 to get 6 equals the square root of x minus 2. Now that it's isolated, I can go ahead and try to get rid of that radical sign. So I'm going to square both sides to get that 36 equals x minus 2. Then I'm going to add 2 to get that x equals 38. So then when I check my answer, I plug 38 in for x. I get 5 equals the square root of 38 minus 2 minus 1. That's going to be the square root of 36 minus 1, which equals 6 minus 1, which equals 5. So we're good to go. X equals 38 is indeed our answer. Checking 1b, this is just like the second half of the example we just did together. This is already isolated, so I'm good to go ahead and just square both sides right there. This becomes x plus 15. I'm going to rewrite this so I know I have to FOIL. My x plus 15 just stays. I got my first. I get 5 times 5 is 25. Plus 5 square root x. Plus 5 square root x. Plus the square root of x squared, because there's 2 of them. I'm going to clean this up a little bit to get x plus 15 equals 25. These combine to give me plus 10 square root x. That simplifies to just be x. So now let's just kind of move some things around. I'm going to go ahead and subtract my 25 here to get x minus 10 equals 10 square root of x plus x. Subtract my x's. Again, those are just going to cancel again, so that's good. Negative 10 equals 10 square root x. Divide by 10. This is -1 equals the square root of x. To get rid of that square root, I square both sides. -1 squared is just 1. So I got x equals 1 there. So then if I check my answer, hopefully this is a little bit easier to check. I just have to plug 1 in for everything. So I get the square root of 1 plus 15 equals 5 plus the square root of 1. This changes to the square root of 16 equals, well, that's just 5 plus 1. So I get 4 equals 6. This is not true. So there's actually no real solution for this problem. So we're really just kind of putting everything together, and now we're just kind of solving equations. We learned all these rules about simplifying radical expressions, and now we're just using all these rules to solve equations. So let's beef up the problems a little bit. With example 2, now we're moving on from just using square roots. So we're moving into our more complex roots. So for this example, we have a cubed root in our equation. So again, the first thing I want to do is I want to isolate the part that either has the radical sign or in this case has our fractional exponent. So let me try to refocus my camera here. Come on. There it goes. So this fractional exponent here, I want to isolate that. So I have to add 4 to both sides to get 2 times, leave all this the same. And then I can divide by 2 to get my parentheses alone. 4 divided by 2 is 2. So here, we know that this 1/3 exponent is the same as taking the cubed root. So the opposite of that would be to raise it to the 3rd exponent. So I'm going to take this whole thing and raise it to the power of 3, knowing that this is going to cancel out. And if I do it to that side, I need to also do it to the right side. So then looking at this here, I can bring that exponent into my inside exponent. So this becomes 6x minus 3 is equal to 3 over 3 for that exponent. 2 cubed is 8. Well, this 3 over 3 is just 1. So this is really just 6x minus 3 equals 8. And now it's just turned into a 2-step equation. So I'm going to add 3. 8, 9, 11. X equals 11 over 6. Just solving that equation, add 3 divided by 6, x equals 11 over 6. And technically, yes, we need to check our answer, but I can tell you right now I'm not going to have many extraneous solutions on there, so we're not going to. But to check our answer, we would just plug this back in for x, make sure it equals 0, which it does, so we are good to go. So why don't you guys go ahead and try these two on your own and see if you can figure them out. All right, so for this first one, the first thing we want to do is subtract the 1. 3n plus 2 to the 1/3 power equals -1. Now we're at the point where we can raise both sides to the 3rd power to get rid of our fractional exponent here. So we're just left with 3n plus 2 to the 3 over 3 power. -1 cubed is just -1. Well, we know this is just 1, so this is really just 3n plus 2 equals -1. Solve for n minus 2. 3n equals -3. Divide by 3. N equals -1. And we're good to go. And again, we should be checking our answer. Plug that -1 back in for n, but it is a solution, so you can just use your calculator to check that to make it nice and easy. So moving over to 2b, again, let's isolate that expression. So we want to add 2 to both sides to get that it equals 2. We're going to divide by 3. Ooh, we got a fraction. Let's go ahead and leave it as a fraction because fractions are not that messy to mess with, so it's okay. We're just going to leave it as a 2/3 fraction. From here, same idea. Hopefully you guys are seeing the pattern. We raise both sides to that 3rd power. All right, raise both sides to that third power. We know that these are just going to cancel. We're left with 5y minus 1. We know that when we multiply this 3 to that fraction exponent right there, it's just going to become 1. That's the whole reason why we're doing it. So we get 5y minus 1 equals, well, I can take this 3 to both the numerator and the denominator. 2 cubed is 8. 3 cubed is 27. You could also just type that into your calculator. It would also do that for you. And now we just have a two-step equation to solve. So I'm going to add 1 to both sides. So I get 5y equals, well, now I got to think about adding fractions. I could use my calculator, or I can say if I'm just adding 1 to this fraction, it's really just 27 over 27. And 8 plus 27 is 35. So this becomes 35 over 27. My last little step here is I want to divide by 5. And I'm just going to do a little bit more mental math here. Maybe I'll confuse you, but it's okay. You can always type that into your calculator. But whenever I'm dividing by two numbers like this, whenever it's like a division problem stacked like this, you just multiply the denominators. So if I have 27 times 5 on the bottom there, I know that 35 divided by 5 is 7. So I can kind of cancel some stuff out there to get that my final answer is 7 over 27. And if I were to plug that in and check it, it would give me what I needed. Again, if I confused you with my mental math with this fraction, go ahead and use your calculator, write it out, do what you need to do, but you should get 7 over 27 as your answer. So to wrap things up for this section and this chapter, one last little problem I want you guys to try. It's more of like a multiple choice type question. So let me get this to focus here again. There, oh, go back. All right, that's better. All right, so we're still just solving here, so I'm going to rewrite this down here so I have some room to work. Again, the first thing I want to do is I want to isolate that radical expression, so I'm going to add 6. And then divide by 3 to get this alone. That's just 2. All right, since I'm taking the 4th root here, when I was taking a cubed root, I cubed it to get rid of it here. And raise it to the 4th exponent because that's what's going to cancel everything out. And if I do it to one side, I have to do it to the other side. That exponent and that radical just cancel out to be left with 2n plus 6. And then 2 to the 4th power, I could type that into my calculator, or I could think about it in my head, is 16, right? Because 2 squared is 4. 4 times 2 is 8. 8 times 2 is 16. Now I can just solve. Subtract 6, 2n equals 10 divided by 2, n equals 5, which makes my answer C. Say, I'm running a little low, and this is an ACT question or a SAT question, running a little low on time. I could just plug and chug and see which one also works to get my answer. That would be a very valid option, but 5 is our answer. So then to wrap up Chapter 6, here is your homework for this section. Page 432, number 1 through 11, you're just doing the odds. I will have the pictures posted on Classroom as well, and email me if you have any questions.